Take a look at this map. You've seen it 1,000 times. It's the map we are all familiar with. It's the default image in your head when you hear the words, the world. And if you look right up here, at the top, you see Greenland. It looks massive, right? In fact, on this map, it appears to be roughly the same size as the entire continent of Africa. But here's the thing. It's not. It's not even close. In reality, you can fit 14 Greenlands inside of Africa. So why does our standard map tell such a massive lie? It's a geometry problem, and to solve it, we have to go back to 1569. Meet Gerardus Mercator, a Flemish geographer living in the age of exploration. And in 1569, sailors were facing a big problem. The Earth is a sphere, but paper is flat. If you've ever tried to peel an orange and flatten the skin perfectly onto a table, you know what happens. It tears, it stretches, it's a mess. Basically, you can't project a 3D surface onto a 2D plane without distorting something. You have to make a sacrifice. You can either keep the sizes correct, or you can keep the directions correct. Mercator made a choice. He sacrificed size to save direction. He created the Mercator projection. On a globe, lines of longitude, the imaginary vertical lines running pole to pole, converge at the top and bottom, like the wedges of an orange. But he forced them to stand up straight. He made them parallel. For sailors, this was revolutionary. It meant that if you drew a straight line on your map, that was the exact compass bearing you needed to sail. And just a quick refresher. A bearing is simply the direction you point your compass. 0 is north, 90 is east. So picture this. You're a captain in the 1600s. You draw a straight line from Spain to the Caribbean. You measure the angle and let's say it's 250 degrees. All you have to do is tell your helmsman, keep the compass on 250. That's it. Because the map lines are straight, you never have to turn the wheel. You can hold that single compass bearing for weeks and you will arrive exactly where your pencil line ended. For a navigator in the middle of the Atlantic, this map wasn't just useful, it was a survival tool. But there was a catch. To make those curving lines stand up straight, Mercator had to stretch the map. And he had to stretch it more and more the further you get from the equator. Think of it like a funhouse mirror. At the equator, the reflection is accurate, but as you get closer to the poles, where Greenland sits, the image is stretched vertically to keep the grid perfectly square. That's why Antarctica looks like an infinite ice wall and why Greenland looks like a continent. So, if we know it's wrong, why is it still the default today? Why do major platforms like Google Maps use a version of this? Because, ironically, we still use it for navigation. When Google Maps launched in 2005, they needed a projection that preserved angles. That way, when you zoomed in to street level, a square city block actually looked square, and north was always up. Now, in 2018, Google Maps actually switched to a globe mode on desktop, so when you zoom all the way out, the world becomes a sphere and Greenland shrinks to its proper size. So, the Mercator map isn't wrong, it's just designed for a specific job, getting from point A to point B. But when we use a navigational tool as our picture of the world, we end up with a slightly distorted view of reality. Some argue that this distortion does more than just mess with our geography skills. It subtly shapes how we perceive global power. On the Mercator projection, the Northern Hemisphere, home to many Western powers, appears to occupy about 2/3 of the map. It visually dominates the global South. Take Russia, for example. It seems larger than all of Africa, but run the numbers, and the illusion shatters. Africa is actually nearly twice as large as Russia. The map suggests a hierarchy that simply doesn't exist in the physical world. In the 1970s, a German historian named Arno Peters argued that the Mercator map wasn't just a navigation tool, but a symbol of colonial bias. He believed it diminished the importance of developing nations. He wanted a map that told the truth about size, so he promoted this. The Gall-Peters projection. It's what's called an equal area map. Here, the sizes are finally accurate, Africa is huge, Europe is tiny, but looking at it, to get the sizes right, Peters had to destroy the shapes. The continents look like they've been hung out on a clothesline to dry. So, if we can't stretch the world, maybe we should just break it. Enter the good Homolocene projection. It looks like a flattened orange peel. It's an interrupted projection. By slicing up the oceans, it minimizes distortion across the land masses. The shapes are good. The sizes are good, but it's ugly. You can't really use it to navigate, and it's a nightmare to look at. So, we went back to the drawing board. We wanted something that just looked nice. In the 1960s, Arthur Robinson designed this, the Robinson projection. It was designed purely for a beauty contest, literally just to look right to the human eye. It sacrifices accurate area and accurate angles for a balanced, visually appealing image. It's a jack of all trades. It's not perfect at anything, but it's not terrible at anything either. But cartographers are perfectionists. They wanted something better than just okay. That's why today, National Geographic uses the Winkel tripel. It offers a strong compromise between area, direction, and distance. It minimizes the distortion across the board better than almost anything else. Or, if you want a modern twist, there's the Equal Earth projection. It's a pseudo-cylindrical map, meaning it curves the sides like a capsule. It keeps the continents at their proper sizes, like Gall-Peters, but maintains pleasing shapes, like Robinson. It's the best of both worlds, but if you really want to break your brain and see the world without any cultural bias at all, you have to look at the Dymaxion map. Created by Buckminster Fuller, it displays the continents on an unfolded icosahedron, basically a 20-sided die. It has minimal distortion, and crucially, it has no up or down. It breaks the idea that north must be on top. Ultimately, the only map that doesn't lie to you isn't a map at all, it's a globe. But since you can't fold a globe and put it in your pocket, we're stuck with the lie. The key is just knowing which lie you're looking at. See you in the next one.